Yes, all the students, today's class will be once again the tough topic we are supposed to take, which is important, which is challenging too. So, first, I request everyone to take the screenshot of what you are able to see on the screen right now. So, first, our topic is efficiency of a transformer. If I'm purchasing any component, let us say the smartphone, we should know what is the efficiency, what is the performance of that particular object. So efficiency is explained as 90% or 95% or 99%. So we'll never get 100% efficiency because every object has got certain losses. So first, what is our today's topic means what are the different losses present in a transformer. So transformer transfers the energy from one circuit to another circuit. So it will transfer 100% of energy? No, it can be 96% or it can be 97%. So because of certain losses present inside a transformer, it cannot operate for 100% effective. So what are the different losses in a transformer we are supposed to study? You will get the question also, explain different losses in a transformer. So in order to understand this one, so first loss I am introducing to you people is circular current loss or eddy current loss. Eddy current is another name is called circular current. So actually current has to flow in a uniform direction. Very first class we have discussed. But what is this eddy current? Is it really existing? Yes, it is existing. But there is no practical use of eddy current to our subject. So first let us observe carefully this three-dimensional figure. No need to draw in the examination, but listen my explanation. Same thing you are supposed to write. What are the losses in a transformer? The first loss is eddy current loss or circular current loss. What is this loss? Now I am starting the explanation. In a transformer, actually, the current has to flow through the primary or secondary windings, which are mentioned here. But in practice, very small amount of current will also flow through the transformer rectangular iron frame. This current flows in circular direction, which is called the eddy current or circular current. This is what you are supposed to write in the examination. What is eddy current loss? In a transformer, practically the current has to flow through the primary winding or secondary winding in a uniform direction. But in practice, very small amount of current can flow through the rectangular iron frame surface. That current flows in circular direction, which is shown here, which is called the current which flows in the rectangular iron frame surface area in a circular direction is called eddy current. This current creates its own magnetic energy or magnetic field, which will reduce the strength of main magnetic field of the transformer. So this current value has to be decreased. So how to decrease this current value? By using laminations. You can see the word laminations. So laminations are mechanical thing. So we are not supposed to study how to create the laminations. So you can see this is a simple diagram of the laminations, the green color which you are going to see. And the current which is flowing through the surface area of the rectangular iron frame is nothing but the eddy current. Eddy currents are reduced by laminations. You can see here, with no lamination, the strength of the eddy current is maximum. With lamination, the value of the eddy current will be minimized. If these eddy currents or circular currents are less, then transformer can transfer maximum energy from one circuit to another circuit. So in the examination, you are supposed to write only theory. What is the eddy current loss? In practice, current should flow through the transformer primary or secondary winding. But in practice, a very small amount of current flows through the transformer rectangular iron frame, which is called eddy current. This current creates its own magnetic field or magnetic energy, which reduces the strength of main magnetic field phi m. So I'll share here. This is the diagram. This is the main magnetic field phi m. But what is our explanation? current will flow through the winding, but in practice, very small amount of current flows through this rectangular iron frame. Current always should flow through the windings, but in practice, very small amount of current flows through the rectangular iron frame, which is called as the eddy current or circular current, which creates its own magnetic field. That magnetic field acts in the opposite direction to main magnetic field. As a result, main magnetic field value starts to decrease. So we provide laminations which will reduce the eddy currents. Is it clear, all of you? Now you please take the screenshot. With explanation only you can understand the topic. Now I am moving to the extension of this particular topic. Okay, so what are the different losses in a transformer is our topic. Now we are just extending the concept. Yes, now come to this point session. All the students, 1 second. So there is no direct textbook for this subject. Anyone read out what is the topic 9.14 here? Losses in a
Losses in a transformer.
So we should select, yes, we should select different textbooks and we are supposed to pick up now. What is our topic? Losses in a transformer. So let me share here. Yes. There are two types of losses. One is, yes, please mute from your end. Please mute. There are two types of losses. One is core loss. Core means again iron material. Core loss or iron loss or magnetic loss or constant loss. Sir, what are these losses? Means now you see, I'm showing the formula for the eddy current loss. There are two types of losses. First loss is core loss or iron loss or magnetic loss or constant loss. Again, this core loss is divided into hysteresis loss and eddy current loss. Sir, which one is important? Repeatedly asked in the examination, what is the definition of eddy current loss? So I've gone beyond the textbook range. I brought you that particular explanation. So you have to remember mathematical formula. What people they mention to us is eddy current loss is given by certain constant into f square, frequency square, and thickness of the material square, and magnetic field intensity square. So you should remember this formula after writing that explanation. Anyone, what is the definition of eddy current loss? In a transformer, current has to flow through the primary and secondary winding, but in practice, very small amount of current flows through the rectangular iron frame. That current which flows in circular direction is called the eddy current or circular current. Eddy current creates its own magnetic field, which reduces the strength of main magnetic field. Eddy currents are reduced by providing laminations. That's all. And this eddy current formula, there is no proof. It is based upon the assumption. We have to remember this one. K B square F square T square. Okay, this finishes the eddy current. No need of these statements here because already we have introduced. Now, hysteresis loss. What is this loss? We already know AC supply means it contains positive of cycle and negative of cycle. The loss created whenever magnetic energy is increasing in positive of cycle and magnetic energy is decreasing during negative of cycle. Increase of magnetic energy value is called magnetization. Whenever magnetic energy value is decreasing, it is called demagnetization. So due to alternating flux setup in the magnetic core in the rectangular iron frame, it undergoes cycle of magnetization, means increase in the magnetic field and decrease in the magnetic field is called the hysteresis loss. So whenever magnetic energy is increasing and decreasing during positive and negative of cycle, energy loss is created, which is called hysteresis loss. We cannot see the hysteresis loss, but we can measure them. So what is the formula for hysteresis loss? Is certain constant b to the power of 1.67. We have to remember this value because based upon certain assumptions, this value is provided without any proof. And it depends upon frequency and the voltage, volume of the core, sorry. So better you remember this explanation because they will ask you in a transformer, how many losses are there? One is, what is the first loss, all of you? core loss or iron loss, or another name is magnetic loss or constant loss. These losses are created on the rectangular iron frame. The losses which are created by rectangular iron frame are called the constant losses, which is divided into hysteresis loss and eddy current loss. I can expect that this topic will be new to understand, but you have to work on this one. So next type of loss we are moving. In a transformer, there are two types of losses. One is core loss or constant loss. Another loss is nothing but, anyone read the name? What is the loss they have mentioned? Another type of loss? Copper
Copper
loss.
losses.
Copper
Copper
loss.
loss. Yes. See, transformer, what I am using? I am using rectangular iron frame first. Rectangular iron frame is called the core loss or constant loss. Okay. And it is again divided into hysteresis loss and eddy current loss. Okay, that part is done. Now in a transformer, I am using the primary winding and secondary winding. So what do you mean by the word copper loss? Means the loss which is created by the copper wire is called the copper losses. So no need to write any definition. Copper loss is another also called as variable loss. If I change the load, the loss also starts to change. So what is the formula for copper loss or heat loss? Already I mentioned. What is the formula here they have written? I square into R. So remember one word, power loss, copper loss, or heat energy, heat loss is called the I square into I square into R. That means whenever current flows through the copper wire, primary or secondary winding, heat energy is created. How much amount of heat energy is created? It is I square into R. So no need to write any definition. They will not ask you define copper loss. You should write the formula. In a transformer, we are having the core loss, copper loss. Core loss is otherwise called, here they have mentioned constant loss, and copper loss are called variable loss. So write only this formula, first formula. What is the formula for copper loss? I square into R. But in a transformer, I'm having primary winding and secondary winding. So I1 square into R1 is primary loss and I2 square into R2 is secondary loss. Okay, so now you remember this third line. What is this one? See, R1E is nothing but R01. Yesterday we have taken R01 and R02. Okay, so I1 square into R01 equal to I2 square into R02. All of you just remember the formula. So what is the copper loss from formula? For primary winding, I1 square into R1, and for secondary winding, I2 square into R2. In general, I1 square into R01 is also equal to I2 square into R02. Now this finishes the introduction to the losses. So how many losses are there in a transformer? All the students? Core loss or constant loss?
Two losses.
And copper loss or variable loss. Copper loss, only one formula we write. Core loss is again divided into eddy current loss and hysteresis loss. Right. So now we move on to the next continuation of the topic, which is most important one. You can take the screenshot of this one also. Right. So what is our topic? External examination from the transformer. They will ask you explain the efficiency and problems on efficiency. This is the most important stage of this transformer unit. Okay, so problems will be asked on this concept only. Anyone, what is the EMF equation of transformer? E is equal to 4.44 F into 5 into N. Okay, right. Now efficiency you have to remember. Sir, why you have to study the efficiency? Means efficiency explains the performance of the transformer, how much power it is transferring and what are the different losses. So what is the formula for efficiency? This symbol is neta. Okay, it is looks like N. The symbol is neta, the symbol. Efficiency of any object is output by input. For a machine, any machine, we will give you the input and we should get the output, but we'll never get the 100% output because of certain losses. So what are those losses in a transformer? Just now we have studied. So for any machine, what is efficiency? Output, the ratio between output and input. When I say the output in our subject, the output means it is the power. Anyone tell me what is the formula for power? DC power means P is equal to V into I. AC power means VI cos theta. Tell me, transformer works with DC supply or AC supply? Anyone?
AC.
AC supply 100%. Transformer will never understand DC current. Okay, so what is output power? We say secondary winding, no, V2 I2 cos theta by what is input power V1 I1 cos theta. Okay, so we say efficiency equal to output by input, output power by input power. And we can also write what is the formula for input now. Input is equal to, we get output, along with output we get certain losses. So input is equal to output plus losses.
Plus loss.
Losses. So after this explanation, step by step I am moving this one. So what is the next modification of this general expression? So efficiency topic is very much important. So now you see efficiency equal to output by input power. Okay. So output can be written as input minus losses, and input can be written as output plus losses. So what I am doing, I am converting output is equal to input minus losses. We have written here. And what is the input power formula? Anyone? Now, how many types of losses are there? Just now I mentioned core loss or iron loss plus copper loss. Yes or no? Total losses in a transformer. Here we are having losses. No, is iron loss plus copper loss. Iron loss or constant loss, which includes eddy current and hysteresis loss. Generally, we can write Wi or Pi. Copper loss. What is the formula for copper loss? Anyone? I square into R. I square into R. I can write I1 square into R1 for primary winding, I2 square into R2 for secondary winding, I1 square into R01 for total winding referred to primary. Okay, now you see losses formula we got, mathematical formula. After getting the formula for the losses, now we'll substitute here. So what is efficiency now? Input minus losses, numerator. So what is the formula for the losses? Iron loss plus copper loss. So input power minus losses by input power is the modified expression so far. So efficiency. Now you see we are writing, yes, efficiency equal to output power by input power. Output power is input power minus losses, iron loss plus copper loss. So what is input power? As I mentioned, what is the formula for input power? V1 is primary winding voltage, I1 is primary winding current. So what is the formula for input power? V1 I1 cos theta. Okay, now where theta is the angle we are assuming here. So we got here, so we can substitute up to this point. So all of you, is it clear? This formula you have to remember, efficiency up to this one. Now you see, for the problems, I will not use directly this formula. So V1 I1 cos theta is also called as the rating. VA rating. Rating means another name is power. What is the power value? What is the power formula here we are having? V1 I1 cos theta. So efficiency, complete formula I am just modifying here. So you see now, let me maximize. Yes, all the students, you please take the screenshot of this one. So efficiency formula is what we have seen just now. V1 I1 cos theta we have written. In the place of V1 I1 cos theta, we can write V1 I1 as VA rating. V1 I1 as VA rating. So today onwards, please do remember what is the formula for efficiency. Efficiency of a transformer equal to VA rating into cos theta by VA rating into cos theta plus how many losses we are having? Iron loss plus copper loss. Copper loss I can also write as I square into R or I2 square into R02. I know that it is quite somewhat difficult to understand here, but I will make you people perfect. No need to worry at all. Right. So first remember this formula. Efficiency, VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss. Copper loss, in the problem they will give you total winding referred to resistance secondary, I2 square into R02. Okay. Now you see all of you. Let us discuss regarding the load. Let us say in my house, I am using all the fans and tube lights. Then the load is called the full load. You see here, full load. Let us say I'm turning on only 50% of the load in my house. Then the load is called off load. So always load is not constant. So we are taking one small n value, which is nothing but a fraction. N is equal to actual load by full load. Actual load right now it is off load. So just remember this formula. N is equal to actual load by full load. I'll explain in between the problem, right? So let me take you to the first problem so that you'll understand first what we are discussing. Any one student tell me the formula for efficiency. Complete formula. VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss. Okay, right. So you'll become perfect. No need to worry. It is the most difficult topic in the unit. I will explain with the problem. Yes. All of you ready now? We are taking one problem. Just in a cool manner, you listen this problem. All of you. Problem is visible to all. All of you check here.
Yes, sir.
Yes, sir.
Okay. Now you see. Just in a cool manner, you do this one. 3300 by 110 volts. Tell me which is it is step up or step down transformer?
Step down.
Step down.
So
Step
primary
down.
yes, primary winding voltage V1 or E1 is 3300 volts, which is they have written V1, and V2 is 110 volts. Okay. Now 60 kVA. K stands for 1000 kilo. And what is the transformer rating means? It is given as VA 60 watts. We say for the bulb. For the transformer, it will be 60 kVA or MVA. So 60 kVA means the power which we can give to the transformer, or transformer which is transferring the power from primary to secondary is how much? 60 kVA. Okay, that is the value. So 60 kVA means here they have written kVA is equal to 60. That is the power rating. You can write rating is equal to 60 kVA. Okay. Single phase transformer as what is the name they have mentioned in the problem? Anyone read out?
Iron
Iron
loss.
loss.
Iron loss.
Just now we have stated iron loss or constant loss or core loss or magnetic loss, all are same losses. Iron loss of, yes please mute, 600 watts. Okay, watt is a unit of power, 600 watts. So I am writing Pi or Wi is equal to 600 watts. Okay. Primary and secondary winding resistances are 3.3 and zero point 0 respectively. So primary and secondary winding means I1 square, R1 they have given and R2 they have given. Now you tell me what they are asking to calculate. This is 10 marks problem, all of you. It takes time to understand. Determine the efficiency of transformer. All of you.
Transformer
Efficiency.
on
So all of
full
you,
load.
yes. Efficiency formula you are supposed to remember. Efficiency after all that introduction, output by input we know. Efficiency equal to VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss. Is it fine, all of you? What is the efficiency formula? VA rating into cos theta by VA rating
into cos theta. VA rating into
cos theta by VA rating into cos theta plus
theta by
VA rating into cos
iron
theta
loss by
plus copper loss. Okay, I'll show you the formula. Now, how they ask the question? Determine the efficiency of transformer on full load. Full load means near your colony you are having the transformer. Now everybody in their house, they are turning on all the lights and fridge and washing machine, everything. Then if you are turning all the devices in your house, then it is called full load. Full load means the value is 1. All of you remember the mathematical value. And full load at 0.8. So 0.8 means what? It is power factor. So without power factor, you cannot explain the power is transferred to your house. So in India, what is the practical value of power factor? Already I mentioned 0.8. So they have given in the problem. So lagging, LAG means inductive load. So in your house, maximum loads are which type of loads? Boring machine, washing machine, induction stove. All these loads are nothing but inductive loads. Therefore, this is they will give you by default. No need to concentrate on this one. First, our aim is to calculate efficiency on full load. So first, all the students, first better to write the formula for the efficiency. First, we will write the formula. I'll show you the formula where it is written. Let us, yes, all of you. Now you see, all of you, all the students, efficiency first will write, then percentage efficiency is into 100. Efficiency formula, you tell me, all of you, VA rating into cos theta. Instead of KVA, we write like this only. What is the efficiency formula? VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss.
Iron loss and copper loss.
Plus copper loss. Okay. So few textbooks they will write KVA, which is nothing but VA rating. So now all of you, first step in the notes, you please write efficiency is equal to VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss, and percentage efficiency is equal to into 100. Okay. Now you see the problem. In the problem, anyone tell me what is the power value given rating? So I'll just bring the question. What is the rating given here in the problem? All of you?
60.
60
60.
kVA. That is kVA. How much we have
60
taken
kVA.
rating? 60. Yes or no? It is very simple. Direct substitution only. But you have to understand the first step. So now you see the problem. Rating is 60 kVA. 60 kVA means K means 1000. So 60 into 10 power 3 into cos theta. Cos theta, how much given in the problem? They have mentioned power factor 0.8. Yes or no? So in the place of cos theta, what I have to put? Anyone tell me? 0.8. Understood, all of you? So you must understand the question here and direct substitution. Once again, I'm taking you back to the problem. So what is the rating, all of you? VA rating 60 kVA, that is 60 into 10 power 3 into, and what is the power factor value they have mentioned? 0.8. Power factor, power factor means what is the formula for power factor? It is cos theta. So here we say, here we said, yes, this is what the problem, the first problem. Be perfect with the problem what we are discussing. So now first I am taking you to the direct formula. Many people they leave the problems here, but it is very simple, right? Yes. Now all of you see kVA rating is how much? 16 to 10 power 3 into cos theta 0.8 by 16 to 10 power 3 into 0.8 plus iron losses and copper losses values we are supposed to find. Anyone tell me what is iron loss given in the problem? They have given directly. Iron loss, how many watts they have given? 600 watts. We have substituted here. We have substituted. Now, for your understanding, let us see how we are calculating copper loss. Copper loss formula, anyone tell me? I1 square into R1 or I2 square into R2. So now I'm just bringing back the problem once again. So first problem, you have to understand thoroughly, right? This is the question. We have written the requirements: R1, resistance of primary R1, resistance of secondary R2, and iron loss how much given? 600 watts. Okay, it is constant. Now you see, I want to calculate copper loss. What is the formula for copper loss? I1 square into R1 or I2 square into R2 or I1 square into R01. R01 is not given in the problem. I am not using that formula. Or I2 square into R02, which is not also given in the problem. What they have given in the problem? Primary winding resistance is how much? 3.3. So I can use I1 square into R1. Or what is the secondary resistance they have given? 0.011 R2. I can also use I2 square into R2. Now you see. So how to calculate the current I1, primary winding current? All of you remember one formula. P is equal to V into I. What is the formula for general formula for the power? P is equal to V into I. From that, I is equal to P by V. I is equal to rating by V. So I am telling the one more formula for the power. Power rating. Rating is equal to V into I. So rating means kVA here. Rating is equal to V into I. All of you write that one. Rating is equal to V into I. So I is equal to rating by V. I is equal to rating by V. So rating means power value. So we get the I1. Is it clear, all of you? So how we are calculating the I1? I1 is equal to rating by V1. Now you tell me what is the formula for I2, anyone? I2 is equal to rating by V2.
By V2.
V2. So I1 is equal to rating, how much they have given? 60 kVA, 16 to 10 power 3 by V1. V1 is 3300. We got the primary winding current. How much primary winding current? 18.18 amperes. 18 point. Okay. 18.18. Now let us calculate I2. Anyone tell me the formula for I2? I2 is equal to rating by V2.
V2 by V2.
Rating by V2. Let me forward
V2.
this one. Yes. Yes. Just a second. Okay, now you see I2, you concentrate on I2. I2 is equal to rating by V2, 60 by what is V2 given in the problem? 110. So which is
510.
545 amperes, 545 amperes. Okay, right. Now you see primary winding copper loss. Copper loss is also called as variable loss. It is not constant. So copper loss formula, what is the formula? All of you tell me. I1 square into R1 or I2 square into R2. So both we have to calculate, because in the problem they have given R1 and R2. Now you tell me, in the problem if they give me the resistance as R01, what I have to do? What is the formula? I1 square into R01. In the problem if they are giving R02, what will be the formula for copper loss? I2 square into I2
I2
square into
square into
R02.
R02.
Okay, but here they have given R1 and R2. Therefore, I am calculating I1 square into R1 and I2 square into R2. So what is the total copper loss? Tell me now. I1 square into R1 plus I2 square into R2. We have to add. So both the losses are added. What is the total copper loss? All the students, how many watts? 4363.6272 watts. This much amount of power is wasted here. Loss. Now, last step is we are entering in the efficiency formula. Now you see, check all the values whether we got or not. Yes. Now you see. Yes, please mute yourself if there is a disturbance. Right. So now efficiency equal to rating, VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss. So VA rating we know 16 to 10 power 3. Cos theta they have given 0.8. And same thing we write, iron loss is given in the problem, how much? 600. But how to calculate copper loss, anyone? Copper loss is equal to I1 square into R1, and copper loss at secondary is equal to I2 square into R2. Both are added. Total copper loss we got, we have substituted. All of you in your calci, you do this one. First, you have to do the complete denominator. Then numerator divided by answer into 100. You must get this one 90.60. Do number of times in the calci, because calci at a time we cannot enter all the values. First complete the denominator, write the denominator in the rough column, and then enter the numerator. Do numerator by denominator. Answer how much? Okay. If you are getting answer 3 divided by 2, let us say, you have to enter shift equal to, then it will show you the value. Check all of you, you are getting same answer or not. So for the day, I will take only one problem. Next class, we'll move to the next problem. So don't be hesitated with the problem, all of you. Anyone tell me what is the formula for efficiency now? Efficiency.
VA rating cos theta by VA
VA
rating
rating
cos theta plus power loss plus
Iron
copper
loss
loss.
plus copper loss. Very good. So VA rating into cos theta by VA rating into cos theta plus iron loss plus copper loss. Okay. So we say right now. Okay. So we have taken the this particular thing. So this is the problem. They have given R1, R2. So we have to calculate I1 and I2 and similar directly entering into the efficiency. So what is the March 8th, all of you? Anyone tell me? So 1 minute, I'll ask the question.
Women's Day.
International
International Women's Day.
Women's
We
Day.
are conducting one event. I'll tell you. Today is also the February 9th. 9 number is a more powerful one. Anyone tell me the 9 table for 1 minute?